and hydrogen. Give the salt and hydrogen. Then it reacts with ammonia to form sodamide and hydrogen. Sodium combines with ammonia to form sodamide, and this is sodamide. Sodamide and hydrogen combines with this to form sodamide and hydrogen. Compounds of sodium and uses of sodium. There are several important compounds of sodium which are useful in chemistry. Examples are sodium oxide, sodium peroxide, sodium hydroxide, sodium chloride, sodium tetrasulfate 6, sodium triazocarbonate 5 or sodium triazonitrate 5, sodium triazocarbonate 4. These are the important compounds of sodium. Use of sodium. 1. It is used to manufacture important compounds such as sodium hydroxide, sodium chloride, etc. 2. Sodium vapor lamps are used for lighting highways and airports. 3. Liquid sodium is used as a coagulant in nuclear reactors. They use it as coagulants in nuclear reactor. 4. It is used to extract titanium from titanium tetrachloride. Chemistry of sodium oxide. Preparation. It is prepared by the reaction of sodium peroxide on sodium. Sodium peroxide plus sodium gives sodium oxide. So when sodium peroxide reacts with sodium, you have sodium oxide. Physical properties. It is a colorless solid with strongly basic properties. Chemical properties. It reacts with water to give sodium hydroxide. It reacts with water to give sodium hydroxide. When sodium oxide reacts with water, it gives sodium hydroxide. Chemistry of sodium peroxide. Preparation. It is prepared by heating sodium in excess oxygen. When sodium is heated in excess oxygen, we have sodium peroxide being formed. So it has to be in excess oxygen. Physical properties. It is a pale yellow solid which is very unstable in air. Sodium peroxide is very unstable in air. Chemical properties and uses. It is very unstable in air by gradually changing to sodium hydroxide and sodium triazocarbonate. That means sodium peroxide is very unstable in air, and when it changes to sodium hydroxide and sodium triazocarbonate 4. To prevent this, it is stored in airtight containers. It is a strong oxidizing agent used in the production of dyes. So one of the uses of sodium peroxide is in the production of dye because of the fact that it is a strong oxidizing agent. 2. It reacts with water to liberate oxygen. However, if the water is ice cold, it forms hydrogen peroxide, which can be used in bleaching. So sodium peroxide reacts with water. Sodium peroxide reacts with water to liberate oxygen. When that is done, we have this, and oxygen will be liberated. But this is done in ice cold water. the reaction that result to this is not done in ice-cold water. In ice-cold water, there is a change in the product formation. We have the formation of hydrogen peroxide, not oxygen. So sodium peroxide in ice cold water, this water is ice cold and it will give a different product. In ice cold water, you have sodium hydroxide plus hydrogen peroxide. You have sodium hydroxide plus hydrogen peroxide. That means this is done not in ice cold water. This is done in an ordinary water. In an ordinary water, sodium peroxide reacts with water to give sodium hydroxide and liberate oxygen. But in ice cold water, sodium hydroxide reacts with water in ice cold water to give sodium hydroxide and hydrogen peroxide. And this is one of the important reactions of sodium peroxide, because the product you have in ice cold water is different from the product you have in water. In water, it gives sodium hydroxide and oxygen, but in ice cold water, it gives sodium hydroxide and hydrogen peroxide, which can be used in bleaching. This is also used in bleaching. 3. It is used in air purifiers, submarines, and portable breathing apparatus, where it combines with carbon 4 oxide to form oxygen and sodium thiazocarbonate 4. In submarines, it combines with carbon 4 oxide in submarines to form oxygen and thiazocarbonate 4. So oxygen and thiazocarbonate 4 will be formed in the process, and that is what is used in the submarine because of the fact that oxygen is required in breathing. Chemistry of sodium hydroxide. It is known as caustic soda. Laboratory preparation. It is prepared by heating an excess slate lime with solution of thiazocarbonate 4. Slate lime is this, thiazocarbonate 4, where you have the production of calcium thiazocarbonate 4 and sodium hydroxide. Before pure sodium hydroxide can be obtained, this comes out as precipitate, which can be filtered off from the solution, and this can be concentrated by evaporation. Physical properties of sodium hydroxide. 1. It is a white crystalline solid. 2. It is deliquescent and melts at about 320 degrees centigrade. Chemical properties. 1. It reacts with acid to form salt and water, which is a neutralization reaction. 2. It reacts with sulfur 4 oxide in limited and excess supply to give sodium sulfate and sodium hydrogen sulfate respectively. Sodium hydroxide in excess give with sulfur 4 oxide, it gives sodium salt plus H2O. This is a normal salt. In the limited supply, it gives sodium hydrogen sort of this. So this reaction is very important because in excess supply you have sodium thiazosulfate 4, but in limited supply, you have sodium hydrogen trisulfate. So this is an acidic salt that is being produced in the limited sodium hydroxide, and a normal salt is being produced in excess of this. So this is another important reaction of the chemistry of sodium hydroxide. Properties and uses of sodium hydroxide. It reacts with carbon 4 oxide to form sodium trisulcarbonate 4. It reacts with carbon 4 oxide to form sodium trisulcarbonate 4. It reacts with carbon 4 oxide to form sodium trisulcarbonate 4 and water. Sodium hydroxide solution reacts with metals such as aluminium, zinc to form sodium aluminate and sodium zincate 2 respectively. Sodium aluminate and sodium zincate 2 respectively, with evolution of hydrogen gas. For this reason, sodium hydroxide should not be kept in aluminium and zinc container, simply because they form sodium aluminate in the case of aluminium, while in the case of zinc they form sodium zincate 2 complex. That is why it is advisable for sodium hydroxide not to be kept in aluminium or zinc containers. Number 5, it precipitates hydroxide.